Hey there, everybody. We're back again talking about electrochemistry. We're on page 5 of the outline right now, which is dealing with electrolysis. And electrolysis is when we run an electric current through a solution and force a chemical reaction to happen. Now, in order to do this, we have to get a little background from physics. We're going to focus on a guy named Michael Faraday, the namesake of the Faraday lectures every year. And we could go on for days and days about Faraday. I just don't have the time. So what we'll do, just to sum it up, is say that he is the person that connected chemistry and physics together, okay? And he measured the charge on a mole of electrons and found it to be 96,485 coulombs. And today that's actually referred to as the Faraday. Now, coulombs. We better talk about some units here from physics. Coulombs, joules, volts, and amperes. Now, the coulomb is a unit of charge. The joule is a unit of energy, although it is also a unit of work and of heat. The volt is the unit of potential. And amperes is the unit of current. So, the basis for a coulomb is actually the charge of an electron. Negative 1.60 times 10 to the minus 19th coulombs is the charge on one electron. Okay? Energy, that comes from force times distance. Okay, volts, potential, that's work per charge. The work that can be done, RK, by an amount of charge. And amps is charge moving per time. Okay, so an amp times, let's make it a times, a second for coulombs. And then Newton times a meter. Here we're going to have a joule per coulomb. And here we're going to have a coulomb per second. Okay? Now, this is going to look a lot like stoichiometry problems. And I don't want to say, it's a little embarrassing to say this, but you can almost fake your way through these problems as long as you know how to make the units work out. And that's not what I want you to be doing, but it's something that does work. Okay, so what mass of zinc 2 ion will be reduced by 1 mole of electrons? We need a reaction always. Zn2 plus 2 electrons gives us Zn. Okay, now we have 1 mole of electrons times, and from this balanced chemical equation, 2 moles of electrons gives us 1 mole of zinc. The good news is you could have written the equation backwards and still get the same answer because you just need the ratio out of it. And to the periodic table, 1 mole of zinc is 65.39 grams of zinc. So moles of electron and moles of electron cancel, moles of zinc, and we come out with basically 32.6 grams of zinc. Okay? So I'm going to pause while you hopefully do number 2 on your own. Okay, thank you for tuning back in. Hope you finished it. We have 0.500 grams of EU3+. So 0.500 grams EU3+. Going to need an equation. EU3+, plus 3 electrons gives us EU. Now, 1 mole of europium, and that's going to be 151.9 grams of europium. And we can say 1 mole of europium needs 3 moles of electrons. Whether we write the 3 plus or not, it's almost not relevant at this point. Grams of europium, moles of europium. And this is going to leave us with 0.00987 moles of electrons. All right, so we're dealing with mole ratios again. Let's start off this next problem having to use the Faraday constant now. Okay, what mass of molten sodium would be produced by electrolyzing, running electric current through molten NaBr with 2 amp current for 2 hours? So we have Na plus an electron turning into Na. We have 2.0, and I very seldom actually write it as amps. I write it as coulombs per second, times 2.0 hours. Now, I need to do some unit conversion. 1 hour's got 3,600 seconds, or you could do 1 hour, 60 minutes, 1 minute, 60 seconds. That works too. So seconds is gone, hours is gone. I got to get rid of coulombs. Okay, 96,485 coulombs per mole of electron. Coulombs now gone. I'm onto the roadmap. Okay, Faraday really lets us take electricity and put it onto the roadmap. Okay, so here 1 mole of electrons for 1 mole of sodium, and 1 mole of sodium is 22.99 grams of sodium. So moles of electron is gone, moles of sodium is gone, and with 2 sig figs based on that, I'm coming up with 3.4 grams of sodium. Okay? All right, so that's page 5. I'd like you to go out and try a few of the problems on page 6 now, and then tune into the next video to see how it is you have done. This is Morgan, signing off.